Good day, and welcome to our virtual presentation of what's new in GVERSE Geomodeling 2019.3. My name is Fred Poland. I'm the Senior Product Manager for the Geological Applications for GeoGraphix. And let me tell you a little bit about myself before we get into the demonstration. I have a bachelor's and a master's degree in geology, an MBA, and a computer information systems degree. I have over 35 years experience in the industry with both major and independent oil companies, and 25 years experience with GeoGraphix as a technical support specialist, a professional services manager, and for the past 12 years as the product manager. I've worked with GeoGraphix in over 25 countries, and like the farmer's insurance guy says, I know a thing or two because I've seen a thing or two. So, with that out of the way, let's get on to our demonstration. So, what is new in version 2019.3 of Geomodeling? We can now display GeoAtlas maps directly in the map view in Geomodeling. You can take any of your inventory of saved GeoAtlas maps, simply open the GMP and display those same layers in the same order as you have in GeoAtlas. We can also open existing X-section cross-sections in Geomodeling, either from a X-section cross-section layer or by simply migrating to the actual cross-section file, selecting one or more cross-sections, and then automatically bringing those into the list of cross-sections in GVERSE Geomodeling. We can also create cross-sections from the new polygonal selection tool. We've had the polygonal selection tool in GeoAtlas from the beginning, which will allow you to draw a polygon around a group of wells, right-click, send them to well base, sort them on lat long, and then send them to X-section. Now, inside of GVERSE Geomodeling, we can use the polygonal selection tool to select the group of wells, right-click, and then decide whether you want those wells sorted in an east-west or a north-south direction, and then immediately open it up in a cross-section in Geomodeling. We can also select wells in a cross-section for tops that have not yet been picked. We can show penetrations of the wells of the currently modeled surface, and then show the wells that have actually been picked. That way we can tell the difference between the wells that are picked and non-picked, so when you make the cross-section line of section, you can focus on those wells that don't have picks yet. We've always been able to use isomap layers as a surface source in Geomodeling, and that's been a great boon because you can bring in surfaces from other applications. However, if you have a large area with a very large isomap grid with many hundreds of thousands, if not millions of grid nodes, sometimes the loading of that isomap layer is very slow, and particularly if you're using that isomap layer for part of your modeling. Now we can actually decimate the isomap layer in a north-south, east-west grid direction, so it very quickly loads and also models much more effectively. Isocore and Isopack maps can be automatically generated inside of GVERSE Geomodeling. This is a great tool because it stays up to date as you pick your surfaces. However, if you have a number of these Isocore or Isopack maps defined in GVERSE Geomodeling, it can slow down the overall performance because the system is going to try to keep everything up to date. Now you can go in there and toggle on and off individual Isocore maps. If you don't need them, just simply turn them off. And then the time that you do need them, turn them back on so you don't have to redefine the Isocore or Isopack map. After we cover the new features in 2019.3 of GVERSE Geomodeling, we're going to go ahead and interpret the subcrop oil play up in the Saskatchewan area of the Williston Basin, just to give you a complete workflow. Now on for the demonstration. This is a map of wells in the Saskatchewan portion of the Williston Basin. Currently, I'm only showing the well spots layer. That layer is usually automatically displayed When you first open up an interpretation, always look for this well spot layer. Now for 2019.3, we have the ability to open a GeoAtlas map. So I'm going to click on Open GeoAtlas Map, browse over to the map I want to open, and we're just going to pick this one right here. Bring it in, and brings in those same layers that are displayed in the GeoAtlas version of this map, in the same order and with the same visibility property. Notice we have an X-section cross-section layer displaying the line of section for two X-section cross-sections. Now down here in the layer selection box, we want to make sure that X-section cross-section layer is selectable. Now to open up an X-section cross-section from this layer, we simply click on it to select it, right-click, and add X-section cross-section to GVERSE Geomodeling. It's going to look and ask, do you want to use the public strat column, or do you want to use do not change, use the active strat column? So we'll go ahead and proceed using the active strat column. Open it up. And we can't go ahead and apply any kind of template. So let's go ahead and just apply the mini dip initial template. And there is our migrated X-section cross-section. Let's go ahead and close this one. Go ahead and save it. Now another way we can open up an X-section cross-section is from the Home ribbon. Go to Add X-section cross-sections button. Then we'll browse over and we will pick up this mini dip X-section cross-section. And there it is. It's already formatted because the formatting that was preserved in the X-section cross-section side is brought over. But we want to be consistent here and apply that same mini dip initial cross-section template. So apply that. Save it, and we'll go ahead and close this one for now. Now another way of creating and opening a cross-section in GVERSE Geomodeling for 2019.3 is to use the polygonal selection tool. This is this tool right here. But first we want to see which wells actually have logs. So we're going to go to the View menu, open up the Local Log Availability button, and this will show us which wells actually have logs on them. So let's just go ahead and do a simple cross-section and say, let's just do this north-south group of wells. Double-click to select them. Right-click, create cross-section, and let's go ahead and do it in north-south direction. Now it's going to open up initially unformatted, so let's again go to the templates, select that mini dip initial template, and apply that. We got a full screen, and save that, and we'll close that. Notice now we have an inventory over here under the cross-section tree. The mini dip, this untitled one, that's the one we made from the polygonal selection, and this migrated X-section 1 cross-section. Next, let's make a cross-section that includes some wells that don't have any picks. Now the detrital over here is our currently active layer. Now I've turned off the contours for it for now. So we'll come up here to the interpretation wells, right-click, and we're going to show penetrations of the surface. So these wells all penetrate the detrital surface. Next, over here on the detrital, we are going to edit the contour options. We're going to go to the point and show the well points. So combining both together, we can see the wells that have the black donut are wells that have the pick in the detrital, and the wells that only have the pink circle with no black donut are wells that are not picked for the detrital. So let's go ahead and pick those wells. So I'll pick this one, and we'll just jump over here and pick this one, and maybe pick up one right here that does have a pick, so it helps us understand which surface is the detrital in the definition. again, we'll apply the template. And there on our surfaces, we'll turn on the detrital. And we see that is the detrital and the one we're using for picking. So now we can use our picking tools and maybe go ahead and use the correlation tool to draw a correlation. Bring it over here and slip it. Pick there. Pick there. And then we're done. We'll go ahead and just save that. And we'll give it a name. We'll just call this unpicked tops. And close it. Next, we're going to set up the geomodel. So I'm going to go back to the Home tab, open up the GeoSurface Model Properties dialog box. Now this is showing the available surfaces from the currently active stratigraphic column. I've got them all turned on, and I'll point out that some surfaces are of type unconformity, some surfaces are of type formation. The formation types are simply stratigraphic surfaces. The unconformity, of course, are erosional surfaces. And it makes a difference when we're doing a subcrop map that you know the difference between surfaces that are unconformities and surfaces that are formations. Now I have this detrital surface from a seismic volume. Now our surface sources can either be from data points, isomap grid, or from a depth converted seismic horizon out of GVERSE geophysics. But for this one, I'm going to take an isomap layer from my 3D AOI. The layer is called the detrital from seismic volume, and I'm going to decimate it on a 2 by 2 grid, so it will load every other east-west grid node and every other north-south grid node, and should load much faster. Now I've already got the surface constraints because I'm going to be doing some modeling in the subsurface, and I'll talk about this when I show you the cross-section. But I've set up the conformance hierarchy so the detrital coming in from the seismic volume, that's sourced from the isomap layer, will control the detrital that's coming in from simply the well-based picks. Likewise, I'm doing a stair-step type of conformance hierarchy, upward stratigraphically from this lower Bakken sand upward to the Madison. This is the hierarchy that is going to truncate against the detrital unconformity, which you'll see once we get to the cross-section. Now we're also going to network the younger detrital unconformity with the older unconformities in the subcrop of the Madison, this unconformity surface, and the super Madison. And over here on the zones map, we're creating two zones map, one from the Madison to the detrital, and the other from the unconformity to the detrital. But for performance purposes, until we need them, we're actually going to turn these off for now. So we're going to toggle off the model zones. Click OK. Now let's turn on the detrital contours. There they are. Let's add some color. Now currently, this surface is being modeled solely from the well-based picks. It's using triangulation and minimum curvature smoothing. And we see we have an eastern plunging nose of a fold here, which may account for some of the production here. But again, it's open to the west, so that does not account for all of it, just based on our well-based picks. But remember, we have that isomap surface coming in from a seismic volume that we're going to incorporate into our modeling tools. So we're going to turn on the conformance tools. We're going to do some unconformity trimming of this detrital surface and all the surfaces in the subcrop against the detrital surface. And we're going to network the younger detrital unconformity against those older subcrop unconformity surfaces, and then we're going to update our model. Now notice, because the detrital coming in from the seismic volume isomap layer is now controlling the conformance of the detrital from our well-based picks, we see that we have now a nice closed structure over here to the west. So let's open up our mini dip and take a look at the sequence stratigraphic interpretation here. I'm going to change my template over to this proportional 2x proportional template. And I'm going to turn on the Seismic backdrop and hang it structurally. And now you can see the effect of the isomap surface coming in from my seismic volume, following very nicely the events showing the detrital surface in the backdrop of the geophysics, and the surfaces that are being truncated against that unconformity. Again, if we look at the surfaces, we're truncating upward from the Bakken sand, the unconformity, the Madison, upward against the detrital. Let's go ahead and close that. We can save it. Now we're going to go back into our Geosurface Model Properties dialog box, and we're going to turn on our zone map. And turn on that detrital to Madison truncation. Now you can see the truncation edge in the subcrop from the Madison surface upward to that detrital unconformity. So there is our sequence stratigraphic interpretation. Again, let's look at our cross section. Let's open up that mini dip again. And you can see as we move from the edge of the Madison across to the other edge of the Madison, where it truncates both on the cross section and on the subcrop isochord map. So finally, we are going to turn off our subcrop map, turn back on the detrital, go to the Home tab and open up the 3D view, and turn on the detrital surface, zoom out to it, maybe do a little more exaggeration on it. Thank you for your attention, and for the next steps, you can maximize your investment by taking advantage of our free online training classes. So go to GVERSE.com and register on the training website. Also, you can request a quote either from products@lmkr.com or contact your local regional sales manager. Thank you again for attending our demonstration, and enjoy the show.